Statics, type 6 forces. So we don't often see too many of these forces questions coming up in statics, and that's because we're used to kind of seeing these in the pulleys and wedges style questions. So in 1992, we were given a body of weight 14 newtons, and it's kept at rest on a smooth plane that's inclined at an angle of alpha to the horizontal. And there's a horizontal force of 7 newtons together with a force of 7 newtons acting up along the line of the greatest slope. And we have to show that cos alpha is equal to 3/5. So what we want to do is draw a diagram so we can see what information has been given to us. So what we have is a plane that's inclined at an angle alpha. We have a body of weight 14 newtons. So therefore we're going to have weight acting down. We have a horizontal force of 7 newtons with the force of 7 newtons acting up along the line. So what we have are two forces, horizontal one and because it's horizontal, what will be interesting to note is that these two angles have to be the same. And that's because they're alternate angles. So I'm going to call this force F, and we'll resolve that in a minute. So we have one more force acting, pushing the block up, and this is acting along the line of the greatest slope. So therefore this is parallel with the slope, and it's a force of 7 newtons also, pushing the block up. And I'm just going to call this force G for the moment. So G is 7 newtons, F is also 7 newtons, and W is the weight is 14 newtons. So what we're going to want to do here is we're going to want to look at our up forces and our down forces and our left forces and our right forces. And therefore we're going to have to resolve two forces here. We're going to have to resolve the weight because that is acting down, and therefore we need parallel and perpendicular to the slope. And we also need to resolve F, the force pushing the block up, because that's horizontal to the ground and we need it parallel and perpendicular to the slope itself. So if we draw a new diagram with our resolved forces, using a different colour when resolving your forces, or use a broken dotted line for the original force. Okay, so I've just made a larger diagram here. So we're going to resolve weight first of all. So I'm going to use a different colour when resolving my weight. I'm just going to go purple here. So if I look at weight, I need perpendicular to the surface and parallel to the inclined plane. And therefore that's my right angle. So your parallel and perpendicular components are always at 90 degrees to each other. If I look to the triangle to the left, I have alpha, 90, and this angle here. And therefore that means that this angle here has to be alpha, because together that would make a 90 degree angle, and 90, and this would be our angle here. So again, that means that this would be the opposite, which will be W sine alpha and W cos alpha. And if I look at resolving my force, and again I'll use the purple when resolving, we're looking at perpendicular to the plane and parallel to the plane. So again, that makes this side the opposite. So it's going to be F sine alpha, and therefore F cos alpha is the parallel component. So now what we have is all our forces acting perpendicular to the plane or parallel to the plane. So let's set up our first law of coplanar forces. So we'll go with our up equals our down. So if we look at our diagram, these are basically going to be the forces that are perpendicular to the plane. So I can see the forces that are perpendicular to the plane is F sine alpha and W cos alpha. And we're missing one more force, and this is our contact force, which is of course the reaction force. So our reaction force, I should have in the first diagram as well, is going to be perpendicular to the plane also. So we have OR is acting up, and we have F sine alpha and W cos alpha acting down. So that means then that we can say that OR must equal W cos alpha and F sine alpha. But we know that W is 14 newtons, and we know that F is 7 newtons. So we call that equation 1. And then if we look at our left equals our right, in other words, our parallel to the plane forces, and we go back to our diagram, well, we can see G is parallel to the plane, F cos alpha is parallel to the plane, and W sine alpha is parallel to the inclined plane. So of course the left forces is G and F cos alpha, and that must equal the right forces, which is W sine alpha. And of course G is 7, F is 7, and W is 14. So again, that'll be equation 2. Now, if we look at what it is we're trying to show here, we're trying to show that cos alpha is equal to 3 over 5. So looking at these two equations, we have an OR in equation 1 and a cos alpha and a sine alpha, and we have no OR in the second one. So even if I was to get sine alpha in terms of cos and OR, when I sub that into equation 2, we would still have these two kind of variables, alpha and OR. So that's not really going to help me very much. So instead, if we look at equation 2 here, and we look at it from the perspective of trig and trying to solve a trig equation, if I bring everything to one side there, it still doesn't really resemble a quadratic or any kind of something in common type equation. So let's look at dividing everything across by 7 there. So we just get 1 plus cos alpha is equal to 2 sine alpha. And still it doesn't really look like anything very familiar in trig yet. So our most commonly used identity is that cos squared theta plus sine squared theta is equal to 1. And we get that from page 13 in our maths tables. So what I do have is a sine and a cos. So let's take sine, for instance. Let's say, okay, well, what happens if I write sine squared on its own? Well, we know we get 1 minus cos squared theta, and we use that all the time. But what we don't use is if I get the square root of both sides there, which is sine theta, would equal 1 minus cos squared theta. So in other words, let's replace this sine alpha here on the left with the square root of 1 minus cos squared alpha. And let's see what happens. Okay, so now I have everything in terms of cos, and I'm looking for cos, right? So there was no point in me getting rid of the cos and writing it in terms of sine, because we're trying to get cos alpha equals 3 over 5. So now I have everything in terms of cos, but I have a square root sign here. So to get rid of that, we're going to square both sides. So if I square the left-hand side, that means I must put brackets around 1 plus cos alpha, and I must multiply it by itself. So therefore that gives me 1 plus cos alpha to be squared. And if I'm squaring the right-hand side, it's everything on the right-hand side multiplied by itself. So that gives me 1 plus 2 cos alpha plus cos squared alpha. And on the right-hand side, that gives me 4 times 1 minus cos squared alpha. Okay, so let's get rid of the brackets here and bring everything to one side. So that gives me 5 cos squared alpha on the left-hand side plus 2 cos alpha minus 3 equals 0. Okay, so now we're looking at something that's very familiar. It's a quadratic, and it's a trig quadratic. So we're going to say, well, what multiplies to give us 5 times minus 3 is minus 15, and what's going to add to give us 2? And clearly it's 5 and minus 3. So that would give me 5 cos squared alpha plus 5 cos alpha minus 3 cos alpha minus 3 equals 0. So grouping the first two and grouping the second two and taking out my highest common factor leaves me with 5 cos alpha times cos alpha plus 1. If I take out minus 3 as being common, I'm left with cos alpha plus 1 also. So again, highest common factor. If I take that out, we have times 5 cos alpha minus 3 equals 0. So therefore we have cos alpha plus 1 equals 0, or 5 cos alpha minus 3 equals 0. And now we can see, lo and behold, cos alpha equals 3 over 5, which is exactly what we wanted. So we don't really need to obviously finish the other one over here, that cos alpha equals minus 1, because we've got what we want here. So this is what we were asked to prove. So it's an interesting question that, again, as I said, these forces questions don't come up too often in statics. And again, it was very heavily focused on solving a trig equation. But a nice question all the same.